this is of Bangalore airport. As you can see, this whole thing is the runway, and this is the airport terminal, and here is the gate where airports get loaded or unloaded. So the whole aim of the aircraft after landing is to reach this place. So after going through the runway, if it stops here, then it will use this path, and that is called a taxiway. So it uses this one and then uses this part of the road and then comes to the airport. So in simple terms, taxiway provides access to aircraft from runway to the loading apron or gate. So that is the whole purpose of taxiway. And exit taxiways are nothing but the first point of exit after the runway. So at this point it exits, and if it lands from this side, it will exit either here, here or here. So these are called exit taxiways. Exit taxiways are located sometimes at various points along the runway. If suppose a bigger aircraft comes, they will clear here, they will stop and clear here. Sometimes small aircraft can clear itself. So the whole objective of that exit taxiway design is to minimize runway occupancy time. So their whole objective is to clear the runway as soon as possible and reach the airport, thereby minimizing runway occupancy time. This whole design of taxiway sometimes determines the capacity of the airport, because as soon as the aircraft keeps landing, they should also exit, otherwise the next landing will be delayed. Now let us see how to design the radius for exit taxiways. As you see, if this is the runway, the exit taxiways are located here. So you want to determine the radius. Sometimes at exit taxiways, there will be high speed clearance also. Even it will sometimes clear at 90 kilometers per hour also. So the radius should be good, so that aircraft should be able to navigate at exit speed. It should not go out of the taxiway. The same rule which applies for curves in roads applies here also, the centrifugal force and all that. So as you know, the radius is determined by V squared by GF. So here V is in meter per second, that is the exit speed. G is the nothing but 9.8 meter per second square, and F is the friction factor. This formula, if you convert this V to kilometer per hour, it will be V squared by 125 F. Applying the values of G, it will be approximately V squared by 125 F, where V is in kilometer per hour. This is the formula which you usually see in books. So this is how the radius is designed. It's as simple as that. Now let us solve a numerical which came in engineering services exam. So they have told that the design exit speed is 90 kilometer per hour and coefficient of friction is 0.13. It's usually 0.13. So let us just apply. It's a simple application of formula. So you know R equal to 125 F. So here V is in kilometer per hour. So 90 square divided by 125 into 0.13. If you solve this, you will get approximately 500 meters. So option B is the correct answer. As you can see, the radius is very large, so that you can accommodate exit speed of 90 kilometers per hour. Another thing is, where should the taxiway be located? We should find an optimal location so that you have the highest rate of acceptance. As you can see, there will be arrival rate. One aircraft lands one after the other. If suppose let us say in 5 minutes some 7 aircrafts land. So per minute it is 7/5, that is the arrival rate. So this exit taxiway, which leads to the gate or apron of the airport, should also have a rate of 7/5 or more. It should have a good acceptance rate and it should be greater than the arrival rate so that you can accept all the aircrafts. So the objective is highest rate of acceptance so that the landing aircraft clears as soon as possible. I will just put that in a graphical way. Let us say x-axis is arrival rate and y-axis is acceptance rate. That is, if aircrafts go one after the other in 1 minute, how much aircrafts the taxiway will accept. So after a point it gets saturated. Like this taxiway can accommodate, let us say, only 10 aircrafts in 5 minutes. So rate is 10/5. It cannot go more than that. After that, even an aircraft lands, it has to wait so that it clears. This will affect the arrival rate. You cannot go beyond this point because of your exit taxiway considerations. So you should take this point as high as possible. That is your aim. So this is called the balance point. And this will determine the capacity or the runway saturation. Thank you guys for watching the video.